Alright, welcome back everybody. Today we're going to go over how to factor polynomials of degree 2, specifically the type where the leading coefficient is not equal to 1. Those are typically the toughest trinomials to factor when you're first getting into factoring. Some people use tricks, shortcuts, all that type of stuff. The method we're about to go through is just straight algebra. So let's get started. So the first thing we do is we identify the a, b, and c values from the standard form of a quadratic expression. So this is going to be our a, this is going to be our b, and this is going to be our c. Once we have a, b, and c set up, we're going to set up the x. And you may be familiar with this method so far. You use this for a lot of factoring. Some people use a box instead. Either way, the value in the top is going to be the result of the product of a times c, whereas the value in the bottom is going to be a result of whatever the b value is. So let's figure those values out right now. So a times c in this case is 2 times negative 12, so that's going to be negative 24. And the b value is positive 5. Essentially, you're looking for two values that both multiply to the product that you see in the top space, but add up to the result you see in the bottom space. So first, we're just going to write out the number 24, and we see 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, we need to ask ourselves, do any of these pairs of factors multiply to negative 24? The answer is no. So there's no way we can actually get a negative 24 currently. So instead, we have to make at least one of these values negative from each of these pairs. These are the only possibilities that we have, possible combinations of negatives and positives that we can have for this problem. And from here, it's just a matter of looking at which one of these pairs of factors add up to the value that we want, which is b equals 5. So the values that we're looking for are negative 3 and 8. So that's what we're going to fill in these empty spaces with. Now, mind you, it doesn't matter what order you fill in those empty spaces with these two values. What does matter is that you get the two correct values and the correct combinations as well. Once you have that, you're good to go. So now the next step, we are going to remind ourselves why we chose negative 3 and 8 in the first place. Negative 3 plus 8 is positive 5. Let's multiply everything by an x. Is negative 3x plus 8x equals 5x. That matches up pretty well with something that we already see in the original expression. That 5x that we see in the original expression is exactly the same as the 5x we see down here. What that means is we could take that 5x in the original expression and break it up, or rather split it into the sum that we see on the left-hand side right here. So that's exactly what we're going to do next. We're going to take the original expression. We're going to write down the 2x squared. We're going to write down the minus 12. We're not messing with those. Those are staying as is for now. And now we're going to take that 5x, the original 5x, and split it into a sum of negative 3x plus 8x. So we have negative 3x plus 8x, because now we can do something else called factor by grouping, right? So from this step, we're going to do exactly that. We're going to factor by grouping. And to do that, we specifically are going to look at the left-hand side and find the greatest common factor there. And then we're going to look at the right-hand side and find the greatest common factor there. So let's look at the first two terms. 2x squared minus 3x. The greatest common factor for those is just going to be x. And you're left with 2x minus 3 on the inside. To the right, we see 8x minus 12. The greatest common factor there is positive 4. So we look at the right-hand side, and the greatest common factor there is a positive 4. So now we notice that we have the Same expression on both sides. We're going to continue this problem again by just factoring. This term, 2x minus 3, we know that that is actually the GCF between both of these two terms. So between both of these two terms, 2x minus 3 is what they both have in common. So we're going to factor that out the same way we factored out the x from earlier and the 4 from earlier. So we're going to identify the 2x minus 3 as our greatest common factor, and we are going to factor it out. And what we're left with is, in fact, the x that you see on the left-hand side and the plus 4 that you see on the right-hand side. And now we are done. But to address one more potential question, if you're wondering if the order of this matters or not, the answer is no. By the commutative property of multiplication, it doesn't matter. 2x minus 3 times x plus 4 is in fact the same thing as x plus 4 times 2x minus 3. As long as you have the correct factors, you're good to go. And that takes us to the end of the problem. Thank you all for watching.